In section 5.4, we're going to talk about the natural exponential function. And what the natural exponential function is it's actually the inverse of the natural log function that we've been talking about. So if you read in this first paragraph I have here, it says the inverse of the natural log function is the natural exponential function, denoted by f inverse of x. And here's our exponential function. If you notice on your calculator, they're actually the same key in order. If you look on your calculator, the ln button, if you hit the shift or the second button, you'll get the exponential function on your calculator. All right, so since they're inverses, we can use that in order to solve for x. All right, well, we want to get x by itself, so we need to somehow get rid of that exponential function. So what we can do is we can take the natural log of both sides. So we can say the natural log of 7 equals the natural log of e to the x plus 1. Well, what these do, these are inverses of each other, so they cancel each other out, to say. So we have the natural log of 7 equals x plus 1. And then all we need to do then is say, all right, let's move 1 over and say the natural log of 7 minus 1 equals x. And you type that in your calculator. Remember, the natural log of 7 is separate than 1, and we can type that into our calculator here and say the natural log of 7 and then subtract 1, and we get 0.9459. Okay? Go back here. And the next problem here, we want to solve for x again. Well, this time we're given a natural log function there. We got to get x by itself. So we do the inverse of natural log function. So we could raise each of these using the exponential function. So we could say e to the natural log of 2x minus 3 equals e to the 5th. All right, well, this e and the natural log functions are inverses of each other, so they cancel out. So we'll have 2x minus 3 equals e to the 5th. And then all we have to do is we do our simple algebra and get x by itself. So we're going to say, we're going to add 3 over, so I'm going to have 2x equals e to the 5th plus 3. And then we're going to divide by 2, so x equals e to the 5th plus 3, e to the 5th plus 3 divided by 2. And again, you can just type that in your calculator and get your answer there. Okay. Couple properties of the exponential function. Sorry about that. I'll make it a little bigger here. Whoops. Couple properties of the exponential function. Just like if we have like an x times an x, we add exponents. So that's the same thing here. All right. E times e, you add the exponents. And the same thing is if I have x squared all over x, all right, we subtract our exponents. We go 2 minus 1 and we get a x, right? So same thing, if we have a exponential function over an exponential function, all right, we go ahead and we subtract the exponents. All right, so let's take a look at the graph here and the properties of the exponential function. All right, its domain is from infinity to negative. That means it's x values. If you look at the graph, that makes sense. It goes from negative infinity all the way to infinity. Can be any of those. Its range can be from 0 to positive infinity. Notice we don't have any negative values for y, so that's its range. All right. The function is continuous, increasing in 1 to 1 on its entire domain. So as you can see, it's increasing. And for every x value, there is a y value, a different y value. All right. And it's increasing continuous. The graph is concave upward on the entire domain, as you can see. And if you notice here, all right, the limit is the exponential function approaches negative infinity to 0. So if you notice here, as we're going far closer and closer here, it looks like we have an asymptote at x equal to y equal to 0. All right, so we have an asymptote at y equal to 0. It's never going to cross over the x-axis. And the limit as x approaches positive infinity is infinity. It goes on to forever. I mean, as we get closer and closer, farther and farther in the positive direction, y is just going to continue to get bigger and bigger and bigger. All right. Also notice that e to the first, or e to the 0 power, so when x is 0, that's 1, because anything to the 0 power is 1. That still holds true. Okay. And then today we're going to talk about the derivative of the natural function, the exponential function. All right. And these are actually pretty easy. If we're just left with an x in the exponent, then it's just e to the x. Now, if we have something else, something different in the exponent, we can make whatever's in the exponent your u and do our u substitution stuff, which I'll show you down here in the example. All right, so we're going to take the derivative of 2x minus 1. So I'm going to go ahead and make this u. So we'll have e to the u, all right, and I'm going to make u equal 2x minus 1. Well, then du equals just 2, right? 2 dx. All right. So what this says right here, all right, when I take the derivative of e to the u power, I get e to the u du dx, right? Well, let's get du dx. So if I divide by dx over here, I have du dx equals 2. So all I need to do is I need to substitute back in. So I get e to the 2x minus 1 because my u comes back in. And then my du dx equals 2, so it needs to go so multiplied by 2. Or I could write it 2 times e to 2x minus 1 like that. Okay? So there's a derivative of that function. Same thing with b here. All right, we're just going to go ahead and we're going to make this our u. All right, so we're going to make u equal negative 3 all over x. So now I have e to the u, and when I take the derivative of that, I get e to the u du dx. All right, so let's find our du dx. So let's take the derivative. So du equals, well, we can move that negative x up into the x, or up into the top. So we'll have a negative 3 to the negative first power. Remember, we take derivatives, we bring the power down and subtract 1 from the power. So we'll have a positive 3x to the negative 2. So my du is going to be a positive 3 all over x squared. Okay? Dx, and then we just bring our dx over and we have du dx. So all I need to say is now I plug in my u and say e to the negative 3 all over x times 3 all over, 3 over x squared. Okay? And we can go ahead and we can write this in a little better form. We can say 3 times e to the negative 3 all over x squared. And that's our derivative there. That's it for this section. It's just derivatives and the properties of the natural exponential function. So I'll see you in class.